Okay, we're going to take a look now at section 10.2, which is going to have us looking at some other ways to write square roots. We're going to look at some rational exponents. All right, problem number 1 jumps straight in there, and it says to evaluate. So we're going to find the value of 25 to the 1/2 power. Now this is the first time in your math classes at MCC, if you've done our classes, the sequence of classes, this is the first time you've ever seen a rational or a fractional exponent. This means square root. This is the square root of 25. If you were to go on and take a good bit more math and you were in calculus, you would rarely ever see a radical written. Instead, you would see the fractional exponent notation. Even though I'm very comfortable with this fractional exponent, in my head, it still switches to radicals because I learned it first. And then you can take the square root of that. The square root of 25 is 5. So
You don't leave it in the box.
you do not leave it in under the radical sign. Anytime you take a square root, the radical sign is gone. It's like freeing the prisoner.
So 1/2 means square root.
Yes, it does. And I'm about to say that, and here's the rule. If you have x to the 1/2 power, that means square root of x. We are going to get a more general rule in just a minute. But the 1/2 power means square root. And you can look at it, well, where would the 2 be over in the radical expression? Wasn't there an implied index of 2 that we don't write? Okay. Where's the 1? I don't know. Maybe we'll figure that out in a minute. It actually is the power of 25. That's where the 1 and the 2 came from. But let's keep going. Problem number 2. It says, evaluate the expression, and it has 1,000 to the 1/3 power. Well, if 1/2 means square root, what do you think 1/3 means? Cube root. So that translates into the cube root of 1,000. And the cube root of 1,000 is 10. Number 3. It has the fraction 16 over 81, and it wants us to raise it to the 1/4 power. Well, what does 1/4 mean? It means that it's 4th root. The 4th root of 16 over 81. And we talked about in the last lesson that if you're supposed to take the root of a fraction, that you take the root of the numerator and the root of the denominator. What's the 4th root of 16? 2. What's the 4th root of 81? 3. On your own, I hope you'll practice with your calculator being able to take all different kinds of roots. In class, I see that some of you are, and some of you, are just using the power sheet, which is fine. You can use the power table when it comes test time. So my online students will always be taking an online test, and those of you in class on this chapter will be taking an online test. And you won't be doing it in a class period. You'll be doing it on your own. But we'll talk more about that a little later. Let's look at number 4. I have 3m to the 1/4, and I need to read the instructions because I don't know what to do with that. It says use radical notation to write the expression. Okay, it doesn't say to evaluate it. It says write it with a radical. Now, something important is going to come out of this. 1/4 is an exponent. What is its base? What is being raised to the 1/4 power? Just the m. Just the m. If 3m were being raised to the 1/4 power, it would look like 3m parentheses 1/4 power. But it doesn't look like that. So the 3 is not being raised to the 1/4 power, so I'm leaving it. How do I write a radical that shows take the 4th, raise m to the 1/4 power? What root is it? It's the 4th root of m. So let's say something. If I have x to the 1/2, it's the square root of x. I don't write the index of 2. If it's x to the 1/3, it's the cube root of x. If it's x to the 1/4, it's the 4th root of x. So, summary, if it's x to the 1/n, it's the nth root of x. So whatever that denominator of the fraction is, that's the root, that's the index. All right, let's look at number 5. It says use radical notation to write the expression, simplify if possible. Parentheses, 49, x to the 6th, all raised to the 1/2 power. What's the base of the exponent 1/2? Okay, now when I say that, I'm saying what's being raised to the 1/2 power. That's what the base is. 49x to the 6th, the whole thing, as opposed to in the previous problem where only the m was being raised. So, don't want to look at that again. All right. So to write it in radical notation, which is what the instructions said first, the index is 2. I don't put a 2. But I do put inside here 49x to the 6th, the whole thing. And now can you simplify that? Yes. What's the square root of 49? What's the square root of x to the 6th? X to the 3rd, and I'm done. 2 things. And the instructions said, write it in radical notation. Simplify it if you can. Now, some of these answers may be a little tedious when you're having to type them into MATLAB because you're going to have to use your exponent key. There is a root key as well that has a little place for you to put the index if you need to. All right, number 6, I have the base, -8, raised to the 1/3 power. Well, what do the instructions say? Use radical notation to write the expression. Simplify if possible. So, on my piece of paper, what root am I going to take? The cube root of -8. And can I simplify that? It's -2. Cube root of -8 is -2. Now, when I get to number 7, before I get to number 7, I want to make a general statement. Or I'm going to say generalize. Suppose I have x, which just stands for any base, and I raise it to, and I'm going to pick some letters, a over b. Now, we haven't been doing this. We've been raising things to the 1 over something. It's important that you know where everything goes. The base is x. Okay, it becomes the radicand. The power has 2 numbers, and they have different roles. The denominator is the index. The numerator can go in one of 2 places. There are different times I like it to be in different places, so let me show you where they can go. One place is inside. It's the actual power of the base. Or, I take the b root of x, I can raise it all to the a power. Now something's going to get raised to the a power. What this says is, it's your choice. There are two pieces to this fraction, and you can use them in whatever order you want. You can raise the base to the power and then take the root, or you can take the root and then raise it to the power. Now, which one do I usually use? I usually use this one. The reason being, if x is a number, I would rather take the root of a smaller number and then raise it to a power than take this base, raise it to a power, let it get really, really big, and then try to take the root. So I like to take the root first, and you'll see that in the next question. Let's look at number, are we on 7?
Yes.
Okay. Evaluate the expression 256 to the 5/4 power. Now there are two ways I could do this. I'll do it both ways, and I think you'll see one way is easier if somebody took your calculator for sure. All right, no matter which way I do it, I'm taking the 4th root of 256. One way is to raise it to the 5th power inside before I take the root, and the other way is to take the root and then raise it to the 5th power. Okay, now, look at this first way. You're going to have a calculator probably. Well, I have to, or I have to get out my scratch paper. I'm going to raise 256 to the 5th power. Oh my goodness. Here's what the calculator gave me. Yeah, the 4th root of, well, it's in scientific notation, 1.0995111628 times 10 to the 12th power. I put in 256 and raised it to the 5th power with my calculator. And it was too big for the display of my calculator. So it gave me some scientific notation gibberish. And then I'm supposed to take the 4th root of that, and here's my reaction to that. Okay? I don't know what's going on. I can't even deal with the number of that magnitude. Okay, so I'm going back to this way. I'm going to take the root first while the number is still manageable. I don't want to raise it to the 5th power, let it get out of control, and then try to take the 4th root. So, take the 4th root of 256. You can use your little power table for that, can't you? And what do you get? 4. So, this is 4 to the 5th power. Can you do that? Can you raise it on your calculator, 4 to the 5th power? Whoops. 1024. Evidently, the 4th root of this big giant number was 1024. But I don't even know what that exact number was because it gave it to me rounded. It got too big for, and I'm using a TI-84, and it got too big for the 84 to display in regular notation. So, when you have a rational exponent, I encourage you, root first, power last. You can do the other one if you have a calculator, but I'd just as soon not. And some smaller calculators wouldn't even be able to put it in scientific notation. All right, let's look at number 8. Numbers more manageable. It says take negative 27 and raise it to the 2/3 power. All right, the way I prefer to do it, it's going to be a cube root of negative 27. I want to take the cube root first, and then what power will I raise it to? Second. So, what's the cube root of negative 27? Negative 3. It's in parentheses. Now square it. 9. Because it is a negative base being squared, it is going to turn into a positive 9. Could you have done it the other way? Yes. You could have taken the cube root of negative 27 and you could have squared it first. So, with my calculator, that's going to be the cube root of, and now it's positive, 729. Use your power chart or use the cube root feature of your calculator. The cube root of 729 is 9. I was able to do it this way, the first way, without ever picking up my calculator. The second way, numbers got bigger. I needed some help, probably.
So it's always got to stay in the parentheses?
Yes.
Yes,
he makes an excellent point. If the base is in parentheses when you start it, make sure that you keep those parentheses going. I could have had parentheses here. They were implied because it was under the radical. Okay, let's look at 9. I have the base of negative 16 raised to the 3/4 power. Well, there we go. How does that translate? Okay, somebody just got an error because you're taking the 4th root of negative 16. Now, it doesn't matter whether the 3 is on the inside or the outside, because can you take the 4th root of a negative base? No. This is not real, which means, according to MATLAB, you would use letter N. Now, some of you may have figured out on your calculator that you could actually use your exponent key and raise the base to the power. That if you have negative 16 and you raise it to the 3 divided by 4 power, you can do that. And because of the negative nature of this base, when that denominator is even, it knows you're taking a 4th root of a negative number, and it will give you an error message.
So if the index is even.
Okay, if the index is even, and in this case, since it's a fraction, if the well, you were right, that is the index. The denominator is the index. If it's even, and the base is negative, automatically not real.
It didn't give me an error that way. It gave me negative 1024.
If you did it this way, did you have parentheses around?
I didn't have it around the 3/4.
Well, either way, it should not have. Did you have it around the 16?
Yes.
Okay. It should give you an error message.
With the parentheses around the 3/4, yes.
Okay. Okay, because here's what happened if you did not have parentheses. If, and this is just reacting to your scenario, if you have negative 16 and you raise it and you write it like that, the calculator thinks that it does exponentiation first. So it raises negative 16 to the 3rd power. All it thinks it's supposed to do is divide that answer by 4. It does not acknowledge that that 4 is part of the exponent. So that's why you were able to get an answer to the first way you had it in. Okay, let's look at 10. I have base, in parentheses, 2x raised to the 3/5 power. Use radical notation, simplify if possible. There are two ways to write this. Okay. I've got a radical sign. Because that 2x is in parentheses, I'm going to leave it in parentheses. What will be the index? What has to be the index? 5. Now, I'm not going to be able to take the fifth root of 2x, am I? So I'm not going to be able to simplify this. When I recognize that I'm not going to be able to simplify it, I put the 3 here. But it would be okay, but I think it might be harder to type in MATLAB, you'd have to put this whole thing in parentheses and put the 3 out there. You can do either one of those. Because remember, you can raise the power, then take the root, or take the root, then raise to the power. It's totally up to you. If I can simplify like I have been able to, then I like to do this one. I like to take the root when I can take it and then raise it to the power. But when I can't, this is a little easier to write. Either one of those would be correct. I can't simplify. That's the answer. Because it said to use radical notation and simplify if possible, and I couldn't simplify. All right, before I do 11, I need to go back to a previous topic and ask you to remember what a negative exponent means. What is x to the negative 2 power? Does anybody happen to really remember that? Okay, a negative exponent says to the base, move me. It does not affect the sign of the answer. It affects the position of the answer. So the base is x. It's being raised to the negative 2 power. That means that it moves down below the fraction line, and it's going to be x to the positive 2. Negative exponent says, move me. Move the base across the fraction line, and the exponent becomes positive. I'm not going to go through the proving part of that I do in 307. I'm hoping I'm just reminding you of something. Okay, so negative exponent says, move me. Number, what are we on? 11? It says, write with a positive exponent, simplify if possible. The base is negative 64. The exponent is negative 2/3. Oh my goodness, we have a lot to do. All right. What does the negative part of this exponent say to do? Doesn't it say drop it down below the fraction line? And it's going to be negative 64 raised to the positive 2/3. When you do move it, the exponent becomes positive. A negative exponent says it's in the wrong part of the fraction. Okay? Now, let's switch into radical notation so we can think about this easier. I have 1 over. The radicand is negative 64. What's the index? And then, what's the power? 2. There's the 2 and the 3. The negative said, move me. The fractional exponent, the 3 became the index, the 2 became the power. You didn't have to put it outside, you could have had it inside. But I think we can simplify this. What's the cube root of negative 64? Negative 4. So it's 1 over negative 4 squared. And that's 1 over what? 16. We had 3 things to do in this. First of all, the negative part of the exponent said, move me to the denominator. And we did. The next thing we had to do was take this rational exponent and put the numbers in the right places. The 3 becomes the index, the 2 becomes the power. Index, power. You can do them in either order. I chose to take the root, then the power. If you did the power first and then the root, you'll get the same answer. So quite a few steps. Negative exponent first says move it, then take the root.
I keep messing up and not putting the -4 in parentheses.
Yes, and if you use a calculator, that's devastating. So if the base is in parentheses to start with, you need to keep it there. All right, let's look at and try to make more sense of this. Let's look at number 12. It says take the base, -36, it's in parentheses, and raise it to the -3/2 power. All right, first thing, exponent is negative. What does that do? It says move it to the bottom. So that's 1 over, keep the base -36, change the exponent to positive 3 over 2. So the negative, all the negative does is say move. And it did. It moved down to the bottom and we got a positive exponent. Now, I'll keep my 1 over. What root am I going to take? Square root. There's an implied 2 here from that denominator that we don't usually write, so I tried to kind of dot it in. Put in the -36, and you're going to then raise that to the 3rd power.
So why would you, I don't understand that.
Okay, let's go back, and maybe I never even said this. I don't think that I did. I'm going to scoot.
All of them are?
Yes, let's scoot down here. If you have x, yeah, I did say this. If you have x to the a over b, the b goes there, the x goes there, and usually the a goes out there, although it could be inside, but I like it outside, which means take the denominator root and raise it to the numerator power. So back up to our question. No real number. This is not real. How come? Because you can't take the square root of a -36. You could take the cube root, but you're not being asked to. So we did all that work, and there's not a real answer to that. All that for nothing. All right, number 13. And you're really going to love it when we get to the very end of this chapter. We're going to learn about those. How do you take the square root of a negative number? Well, we're going to be able to do it. It just won't be real. We have to invent new numbers. We're going to call them imaginary. Just what you wanted. Maybe it'll be a Halloween topic. All right. We have 1 over b to the -4/5. All right, negative exponent. What does it say to do? It says move me. Well, it's in the bottom. So if it's in the bottom and you have to move it, where will it go? Go up to the top. It gets multiplied by whatever's out up there, which was a 1. So it becomes b to the +4/5. What's left in the denominator? A 1, an implied 1, which I'm not going to write. Okay. Now, let me read the instructions more carefully. It says, write with positive exponents, simplify if possible. Okay, I wrote it with a positive exponent. Am I going to be able to take the 5th root of b and raise that to the 4th power and get something? No, I'm done. I can't simplify that. I put it into radical notation so that I can work through the simplifying process. And this one, you can't simplify. Please be sure that you read the instructions on each question so that you'll know what you're supposed to do. Number 14. Okay, we have, is that +7? Yeah, 7 over 2x to the -2/3 power. Instructions. Whoops, oh well. Write with positive exponents, simplify if possible. Okay. Well, You see a negative exponent. Negative exponents are forbidden. What is being raised to the negative 2/3 power? Just x. How do I know the 2 wasn't being raised? No parentheses. Okay. So, does everybody agree that only the x to the 2/3 moves? The 7 stays where it is. The 2 stays where it is. The x to the 2/3 moves up here and becomes x to the positive 2/3. Because I'm just raising a variable to this rational power, am I going to be able to simplify it? Can I take the cube root of x, get an answer, and square that? No, I'm done. That looked like a hard problem. It wasn't difficult at all. Certain amount you have to understand, but not real long. Okay. I want to review, and I have been doing this a little bit as we go along, but I want to review properties of exponents. Some of them we've already reviewed. I want to look at the product rule. I'm going to go through them kind of quickly. If I have x to the a times x to the b, whoops, those bases are the same, what do you do with the exponents? X to the a plus b. The quotient rule. If I have x to the a over x to the b, what do I get? Subtract x to the a minus b. The power rule we have talked about. If you have x to the a and you raise it to the b power, what do you get? X to the a times b. And we had the negative exponent rule, which we've already talked about, which says x to the negative a is 1 over x to the positive a. We're about to use all these rules, but the exponents we're going to look at are going to be fractions. So I might have to add fractions, subtract fractions, multiply fractions. And we can do all that. We might not be doing it with a smile, but we can do it. All right, number 15. It says, use the properties of exponents to simplify. I have x to the negative 6/5 times x to the 11/5. Let's use the product rule. The product rule. I know I see a negative exponent, but that's the very last thing I worry about. Let's see the product rule. What am I supposed to do when I have x to the a times x to the b? I'm supposed to add them. So I'm going to get x to the negative 6/5 plus 11/5. Well, we have been given a gift of a common denominator. Those already have the same denominator. And since those are both 5s, all I have to do is perform the arithmetic with their numerators, and I'm going to have x to the, what is negative 6 plus 11? It is 5. And it stays over 5. But 5 over 5 is 1, so that's x. So this was the product rule. I know they're on the 307 blue sheet, but I imagine that by now I'm thinking you should know them. So you have them in your notes now to review. Let's look at 16. Use the properties of exponents. I have y to the 1/7 over y to the 1/14. Okay? What rule am I going to use? Quotient. And the quotient set rule says to do what? Subtract. So I have y to the, always the numerator 1/7 minus the denominator 1/14. I was not given the same gift this time, but hopefully not a real big deal. Okay, I'm going to go over here to the side. I have 1/7 minus 1/14. What's the common denominator? 14. 7 goes into 14 2 times, and 2 times 1 is 2. No change here. That's, I put the negative with the numerator. What's 2/14 minus 1/14? 1/14. So this is y to the 1/14 power. And write it with positive exponents, so I'm done. Typing that into MATLAB, you will have to use your power key or your power little button. You're also going to, once you get up here, you're going to have to then use the fraction bar, the fraction thing. So it'll be tedious. Okay, I think we will stop there, and I will, the video for lesson 10.2 will come in 2 parts because I'll need to finish it next time. Okay? So I hope that you'll work on MATLAB and that you will go through number, whatever we just did, 16 on this. I've got to find a way to stop the video. Nope.